Dear student, now I will discuss a new chapter, that is your surface chemistry. What is the surface chemistry? It is the branch of chemistry which deals with the study of nature of surface and changes occurring on the surface. That is called surface chemistry. It is the branch of chemistry which deals with the study of nature of surface and changes occurring on the surface. At first I will discuss about the adsorption. For better understanding of adsorption, suppose I will take an example. This is your pen. Suppose I want to coat a red color over the pen. Then what will happen? The red color particles come in contact with the surface of the pen, but remember the red color particle do not enter into the bulk of the pen. This is an example of adsorption. In this case, what will happen? The red color particles adhering the surface of the pen. That means adsorption is an adhering process. So I can write the phenomenon of adhering the gaseous or liquid on the surface of solid is called adsorption. In adsorption, two important parts are present. One is your adsorbate, another is your adsorbent. In this case, the red color particles are called adsorbate and the surface of the pen acts as adsorbent. That means the substance which get adsorbed on the surface of adsorbent is called adsorbate. On the other hand, the substance on the surface of which the adsorption takes place, that is called adsorbent. The common surface between the color layer and the surface of the pen is called interface. That means interface is a common surface in between two phases at which the adsorb molecule concentrate. Next I will explain about the types of adsorption. Depending upon the nature of force existing in between adsorbate and adsorbent, the adsorption is classified into two types. Number one is your physical adsorption, that is also called physisorption. Second is your chemical adsorption, that is also called chemisorption. Now I will discuss about the physical adsorption. Simultaneously I also will discuss about the chemical exertion. What is physical exertion, and also I will discuss what are the related points to the physical exertion. Simultaneously, I also will discuss what is chemical exertion and what are the points related to the chemical exertion. For better understanding, suppose I will take example. Exertion of hydrogen on charcoal. Take another example for chemical exertion. Exertion of hydrogen by metal like nickel, platinum, palladium, etc. At first I will discuss about the first point related to the physical exertion and chemical exertion. When the particles of the adsorbate are held to the surface of the adsorbent by physical force like van der Waals force, then that type of exertion is called physical exertion. In physical exertion, van der Waals force play an important role. That's why physical exertion is also called van der Waals exertion. On the other hand, if the adsorbate particles are held to the surface of the adsorbent by chemical force, then the exertion is called chemical exertion. That means in this case there is a weak attraction between hydrogen and charcoal, but in this case a strong attraction between hydrogen and the metal. If there is no bond will form between hydrogen and nickel, then chemical exertion will not possible. But on the other hand, in this case, that means in physical exertion, there is no requirement of formation of strong bond in between hydrogen and charcoal. Van der Waals force is a weak force. In physical exertion, attraction between adsorbate and adsorbent is very weak. Due to weak bond, the molar heat of exertion is also low, that is 20 to 40 kilojoule mole inverse. On the other hand, in chemical exertion, the attraction between adsorbate and adsorbent is very strong. That's why the molar heat of exertion is very high. The value ranges in between 200 to 400 kilojoule mole inverse. Remember an important point, chemical exertion is also called Langmuir exertion because it is related to the Langmuir exertion isotherm. Physical exertion is a reversible process. On the other hand, chemical exertion is an irreversible process. That means in this case we can remove the hydrogen from the charcoal, but in this case we cannot remove the hydrogen from the metal like nickel, platinum, palladium. Physical exertion generally occur at a low temperature. That means physical exertion decreases with the increase of the temperature. On the other hand, chemical exertion initially increases with the increase in the temperature up to a certain limit, then start decreases. The extent of physical exertion depends upon ease of liquefaction of a gas. But remember, in chemical exertion, the extent of exertion do not depends upon the ease of liquefaction. That means there is no correlation between chemical exertion and the ease of liquefaction. Physical exertion is not specific. That means all the gases can get adsorbed on the surface of solid to some extent. On the other hand, chemical exertion is specific in nature. That means a particular adsorbate will adsorb on the surface of particular adsorbent. If there is no formation of chemical bond between adsorbate and adsorbent molecule, then there is no chance of chemical exertion. In physical exertion, the state of adsorbate is equal in the bulk. On the other hand, in chemical exertion, state of adsorbate is not equal in the bulk. Physical exertion forms multi-layer. On the other hand, chemical exertion form mono-layer. In case of physical exertion, rate of exertion increases with the increase of pressure up to a certain limit, then remain constant. On the other hand, in chemical exertion, rate of exertion decreases with the increase of pressure. In case of physical exertion, activation energy is not necessary. On the other hand, in chemical exertion, activation energy is highly necessary. Basing upon the concentration of adsorbate, exertion can be classified into two types. Number one is positive exertion. Number two is negative exertion. If the concentration of adsorbate is more in surface than in the ball, then such type of exertion is called positive exertion. If the concentration of adsorbate is less in surface than in ball, then such type of exertion is called negative exertion. Negative exertion generally observed in case of solution. Next I will discuss about Jepson, a process in which both exertion and absorption takes place. That type of process is called Jepson. Example of Jepson is dye gets adsorbed as well as absorbed cotton fibers. Second example is your hydrogen is absorbed as well as absorbed by charcoal. These are the example of absorption. Next I will discuss about the desorption. Desorption is the process in which the adsorbed molecule is separated from the surface of adsorbent. Desorption is the reverse of adsorption. Desorption can be possible by heating or by decreasing the pressure. Next I will discuss about the difference between adsorption and absorption. This is your adsorption and this is your absorption. For better understanding, I will take an example, that is your adsorption of water vapor by silica gel. On the other hand, I will take another example for absorption of water vapor by calcium chloride. At first I will discuss about the first point, the phenomenon of adhering the gas or liquid substance on the surface of solid is called adsorption. On the other hand, absorption is an intermixing process in which one substance is intermixed throughout the body of another substance. Next point is your adsorption is a surface phenomenon. On the other hand, absorption is a ball phenomenon. In adsorption, the concentration of adsorbate is unequal throughout the ball. At the beginning, rate of adsorption is high and then decreases till equilibrium is attained. On the other hand, in absorption, the rate is same throughout the process. Adsorption is an exothermic process. On the other hand, absorption is an endothermic process. These are the difference between adsorption and absorption. Next I will explain about the factor affecting the adsorption of gases on solid. What are the factors affecting the adsorption of gases on solid? First factor is your pressure. There is no relation of extent of adsorption with the pressure in case of chemical adsorption. But if you think about the physical adsorption, then in case of physical adsorption, at low pressure, extent of adsorption is direct proportional to the pressure. This relation is valid up to moderate pressure in case of physical adsorption. However, at high pressure, the extent of adsorption tend to achieve a limiting value due to saturation of surface of adsorbent by the adsorbate molecule. Next factor is your temperature. In case of physical exertion, if I will increase the temperature value, then the extent of exertion decreases because there is no necessary of activation energy. But if I will think about the chemical exertion, in case of chemical exertion, there is necessary of activation energy. So, if I will increase the temperature, initially the extent of exertion increases in case of chemical exertion. But after gaining the activation energy, the molecules starts to form the bond with each other. That means the adsorbate molecule starts to form bond with the molecule of adsorbent. After the formation of chemical bond, there is a possibility of formation of adsorption, that is your chemical adsorption. After chemical adsorption, there is no necessity of activation energy. So when you will increase the temperature, then the chemical bond will break. As a result, if you will increase the temperature after the chemical adsorption, then the chemical adsorption decreases. That means at initial condition, if you will increase the temperature, then chemical adsorption goes on increases, but after that, if you will increase the temperature, then chemical adsorption decreases. That means initially chemical adsorption increases with the increase of temperature, but then decreases. This is due to the necessity of activation energy in chemical exertion. Next is your concentration of adsorbent. More is the concentration of adsorbent, more is the adsorption. That means if we increase the concentration of adsorbent, then more adsorbent sites are possible for adsorption of the adsorbate molecule. Next factor is your surface area of adsorbent. If the size of adsorbent decreases, then the surface area of the adsorbent increases. That means more is the adsorption. For example, finely divided nickel, platinum, etc. and porous substance provide a larger surface area for adsorption. Next factor is your nature of gas. In case of physical exertion, there is no specific for a particular exertion. That means all the gases can adsorb with the surface of adsorbent to some extent. But in case of chemical exertion, there is a specific gases can adsorb with the surface of adsorbent, because there is a formation of chemical bond in between the adsorbate and adsorbent molecule. That means if a gas will not form a bond with the adsorbent molecule, then such type of gas cannot participate in the chemical exertion. Remember an important point: readily soluble and easily liquefiable gases like NH3, HCl, SO2, Cl2, etc. are more adsorbed as compared to the gas like N2, O2, H2, etc. Next factor is your activation of adsorbent. More is the activation of adsorbent, more is the adsorption. Activation of adsorbents means increase the adsorbing power. Of the surface of the adsorbent is called activation of adsorbent. How can you increase the activation of adsorbent? There are different ways to increase the activation of adsorbent. Number one is by mechanically rubbing or making surface of adsorbent rough and porous. Second is by using adsorbent in the form of finely divided. Next is by passing super heat in the surface of adsorbent. These are the different methods by which we increase the activation of the adsorbent. Next I will explain about the application of adsorption. First application is your gas mask, which is used to remove the toxic gases like CO, CH4, etc. This is based upon adsorption. Next is your fourth flotation method is used in the extraction of metal. This is also based upon adsorption. Next point is your ion exchange method, which is used for softening of hard water. This is also based upon adsorption. Next is your adsorption chromatography. Is generally used to purify and separate the pigments and hormones. This is also based upon adsorption. Next is your adsorption indicator. Is also used in many volumetric analysis. Next is your a large number of drugs and medicine also function on the basis of adsorption. Next is your dyeing of cotton fibers are also based upon adsorption. Next is your removal of color substance from cane sugar by animal charcoal can also explain by the help of adsorption. Next application is the principle of adsorption is useful in heterogeneous catalysis reaction. Next application is your silica gel and alumina is used to remove the moisture and humidity from the air. This is also based upon adsorption. These are the different application of adsorption. Next I will explain about the catalyst. Catalyst are the substance which can alter the rate of reaction without himself undergoing any change. Catalysts are two types. One is a positive catalyst, another is a negative catalyst. Positive catalysts are used to accelerate the rate of reaction. On the other hand, negative catalysts retard the rate of reaction. Next I will explain about the characteristics of catalyst. What are the characteristics of catalyst? First point is it is unaffected during reaction. Second point is small amount of catalysts are generally used in the reaction. Catalysts do not change the state of equilibrium. Catalysts do not change the state of equilibrium. Catalysts do not initiate the reaction. Even in the absence of catalyst, a reaction can proceed slowly. Next is your catalysts are used in temporarily in a reaction. Catalysts are generally caused by other substance during the use of catalyst in the reaction. Catalysts are specific in nature because for a particular reaction we generally use a particular catalyst. Catalysts do not change the nature of product. Catalyst shows maximum catalytic activity at optimum temperature. The catalytic activity of a catalyst can be increased by a substance that is called promoter. Take an example, N2 plus 3H2 gives it 2NH3 in the presence of iron and molybdenum. Here iron is the catalyst, molybdenum is used to increase the catalytic activity of iron. So here molybdenum acts as a promoter. These are the characteristics of catalysts. Next I will explain about the types of catalysis. There are two types of catalysis. Number one is homogeneous catalysis. Number two is heterogeneous catalysis. The reaction in which both reactant and catalyst are present in the same state are called homogeneous catalysis. On the other hand, in In case of heterogeneous catalyst, the reactant and the catalyst belongs to different state. Now I will take an example. SO2 gas plus O2 gas gives SO3 gas. It is done in the presence of catalyst NO, which is also belongs to gaseous state. Look at that. In this case, both the reactant SO2 and O2 and also the catalyst NO belongs to gaseous state. That means in this case, both reactant and catalyst are present in the same state. So this reaction is called homogeneous catalysis. Take another example, Ca3COO C2H5. This is your an ester. It belongs to liquid state. When it is subjected to hydrolysis, then it gives acetic acid plus ethyl alcohol. Your acid is used as an catalyst. Suppose this comes from an acid, that is your HCl. It is present in the aqueous state. Look at that. In this case, the state of reactant and catalyst are same. So this reaction belongs to homogeneous catalysis. Take other example related to the heterogeneous catalysis. N2 plus 3H2 gives it to NH3. Your N2 belongs to gaseous state, H2 belongs to gaseous state. This is done in the presence of iron catalyst, and here also a promoter is used, that is your molybdenum. Look at that. In this case, the state of reactant and catalyst are different. So this reaction belongs to your heterogeneous catalysis. Next I will explain about the enzyme catalyst. Enzyme catalysts are generally found in the form of homogeneous catalyst, which generally refers to the catalytic chemistry that control the rate of all reaction occurring in the living system. Enzyme catalysts are complex nitrogenous organic substance which generally produced in the living plant and animal. All the biochemical reactions are generally enzyme catalysis reaction. Take an example which is related to the enzyme catalysis reaction. Preparation of ethyl alcohol from cane sugar. Cane sugar contains sucrose. Sucrose having formula C12H22O11. When it is subjected to hydrolysis in the presence of inverted enzyme, then it gives glucose and fructose. This is your sucrose. Now the glucose in the presence of zymes gives 2 molecules of ethyl alcohol and 2 molecules of carbon dioxide. Look at that, your enzyme catalysts are used. Next I will explain about the characteristics of enzyme catalyst. First point is your enzyme catalysts are highly reactive. Second point is your like inorganic catalyst, enzyme catalysts do not do not change the final state of equilibrium of a reversible reaction. Third point is they are specific in nature. That means for a particular reaction, particular enzyme catalyst is used. They are highly specific to temperature. That means for a particular temperature, it gives its maximum efficiency. That temperature is called optimum temperature. The substance which are used to increase the catalytic property of enzyme catalyst are called coenzyme. Generally, small amount of catalyst is sufficient for a large reaction. Enzyme catalysts are destroyed by UV ray. The efficiency of enzyme catalyst decreases in the presence of electrolyte. These are the characteristics of enzyme catalysts.